Welcome to Potato Baking for Roon. In this video, I'm going to show you how to put some parts together to make an endpoint for Roon. We've done this in the past with Raspberry Pi boards, but Raspberry Pi boards are getting pretty tough to come by. I'm hoping sometime in the next few months or later this year, at least in the US, they'll be more affordable. Right now, a typical Raspberry Pi board will cost upwards of $100 more than the original retail price. So this is a nice alternative to using a Raspberry Pi board, at least until those boards become more accessible. So the goal for this video is for me to show you how to take this pile of parts and make it into this. But first of all, you may be wondering why you would even want to do that. Let me explain. Here's a typical DAC, one of the DACs that I have in one of my systems. If you look on the back under the digital input section there, you can see we've got optical, I2S, AES EBU, there are a couple of SPDIF inputs, coax and toslink. There's even a Bluetooth input, but conspicuously absent from this DAC and most of the DACs that I own is an Ethernet connection. There's no way to connect this DAC to the network. Why is that important? That's important because Roon can't see a DAC unless it's on the network. Roon is a network player that depends on all output devices to be accessible over your home Ethernet or Wi-Fi network. Ideally wired network, but Wi-Fi can work as well. This DAC it's a great DAC, but it has no ability to connect it to a network. I actually think that's a good idea from an architectural perspective, because if you think about it, if a DAC has a network connection or a network port on the back of it, what it really has is a small computer like this somewhere inside of it. There has to be a small computer inside to handle the TCP/IP stack and do all of the networking stuff. This small computer, even though it's pretty low powered, can produce noise, and it's a lot of extra work for the DAC manufacturer to separate the noise that the small computer makes from the other circuitry inside of the DAC. Manufacturers do it and they're successful at it, but it adds a significant amount of cost. The other problem is the software on this needs to be updated more frequently than firmware in a DAC typically. It needs to be updated to handle security patches and stuff like that. And if the manufacturer of the DAC, who's an audio company, falls behind on providing these updates, then at some point your expensive networked DAC can become a doorstop. It can become not very useful, or you'll have to attach a device like this to the back of it to make it useful again. So why not just keep this device in a separate box anyway? The other thing that's nice about having this in a separate box is that whatever noise it does produce can be mitigated by the inverse square law, by placing this device maybe a meter or so, a few feet away from the DAC, rather than having it crammed inside of the DAC, where any noise that it generates is going to be more significant. So if we have that little streamer as a separate box, we can connect it to the DAC like this over USB, and now this DAC is a network DAC. In this case right here, I'm using a little USB dongle, but I could also use an Ethernet cable. You can see to the left of that USB dongle, there's an Ethernet port, RJ45 port, that I could plug a network cable into. And that's actually, for Roon, the preferred connection, but it's nice to have the flexibility to do this either way. So again, why would you want to do this? Why couldn't you just connect this DAC to a laptop computer? Well, the reason is, or one of many reasons, there are a bunch of them, but one of the significant reasons is power draw. So I've got my little handy dandy kilowatt device, and I've measured the output or the power draw from that little potato board or that little small computer that you saw in the previous picture. And this is the highest reading that I could get from it. It'll kind of flick back and forth between 1.7 and 1.8 watts. 1 watt is, or 2 watts, it's under 2 watts, is basically negligible power. Even a little nightlight is going to draw 10 watts of power. So it's safe to leave this little device on all the time. It's not going to run up your power bill. The other thing about its small power draw is that less energy going into the device means that there's less energy that can leak out of it in the form of radio frequency interference or electromagnetic interference. There's just not much energy to pollute the environment around it. I've got a Dell XP15 laptop, so I plugged it in to the same kilowatt, and this was, the power flicked around a little bit, but this was kind of an average level that I saw for power draw from the Dell. This was with the battery fully charged. However, even with the battery fully charged, every once in a while I'd see the power go up to around 40 or so watts. So you can see that the Dell draws anywhere between 10 and 20 times as much power as the kilowatt device. And I imagine this is probably typical of general purpose computers. So while you could use a laptop or a desktop computer as a endpoint to drive a DAC, you really wouldn't want to do that all the time because the power draw is so high. It's better just to have a little small headless endpoint that you can leave connected to the DAC and then have your DAC accessible from Roon all of the time. So what I'm going to do next is go ahead and show you an unboxing of all those parts and kind of walk you through what we have. I'll also provide a link to where you can get a parts list and purchase those for yourself. So let me get that started. These are the parts for our project. I'm going to put the URL up at the top of the screen that has a parts list so that you could buy these parts and follow along at home if you wish. And what I'm going to do next is just get started walking you through what these different parts are. This is the Libra Computer La Potato board that we're going to be using for the project. It's very similar to a Raspberry Pi 3, but it's missing a few components. The nice thing is it's only $30, so it's pretty inexpensive. There's GPIO headers on the back that you can see kind of in this rough diagram here. We'll take a look at this closer later on. Unfortunately, these are not compatible with Raspberry Pi audio hats, so we'll have to use the USB ports for our project. I purchased the 1 gigabyte version, but there's a 2 gigabyte version that's available for $5 more. This is a heatsink that we'll put on this board to help keep it cool. It's not critical, but it's helpful. I want to talk to you a little bit about storage for this because we've got a couple of different options here. I bought the 64 gig SanDisk microSD card. I don't need that much space, but it wasn't much more expensive. So I'll probably use it for some other project. But I also bought this eMMC module. eMMC storage is way faster than microSD, so we'll upgrade to this eMMC module later on. I picked this particular SanDisk high endurance card because small board computers tend to do a fair bit of writes to the microSD card. We don't need a lot of throughput or speed, but we do need endurance. We do need to have a card that will take a long time for us to run out of writable cells. Typically with a flash storage, you only have 100 or so, maybe 1,000 rewrites before the card goes bad. So this card will last a lot longer. But eMMC storage is about 10 times faster and also handles a lot of writes. So this will be a nice upgrade later on. Not critical for our audio project, but it'll be nice to have. We also have got a USB audio adapter. Again, there's no USB on the board, so we're going to use this for Wi-Fi connectivity. Not critical. We may use the network port later. This is just a little case. We'll use this case later on in the project. We're not going to use the case right away, but it was an inexpensive case that works well and looks good for this project. In this box, we have a 5-volt, 3-amp power supply. This one's from Allo, and I like this power supply because it has, but according to the manufacturer, lower than normal ripple noise. It's just got a barrel connector on the end, but we've got a couple of adapters for micro USB as well as USB-C. And then there's some adapters for different countries if you want to use those someplace else. Get back in there. I'm going to go ahead and unbox these things real quick for you, get them open so you can see what you can expect when you get these parts in. The Libra Computer is in this little bag that we'll need to cut open, anti-static bag. And there's a little rectangular piece of foam in here as well to help protect it. We'll just set that aside. It's a pretty nice looking board. The manufacturing quality seems to be really high, especially for the price of only $30. And then we'll open up our SanDisk card. These things are always challenging. I end up just having to cut the packaging open like this to get in there. We got a little SD to microSD adapter as well. That'll be helpful. We'll use that as part of the flashing process. At least the laptops that I have a SD card slot, but not a microSD card slot. So this little adapter makes that process pretty easy without having to buy a separate adapter. These things are tough to get out. I'll just make another cut here. Get this little guy out of here. These things are so small, they're easy to lose track of. So I'm going to go ahead and put it in the adapter now just so that I don't lose it. There we go, tucked away. And here's our little USB adapter. This adapter is based on a Realtek chipset that is compatible by default with Linux, which is why I picked this one. And the performance is really good as well. I've been able to stream all high-res formats up to 32-bit 768 kilohertz PCM or DSD512 over this little guy with no issues. We'll set the eMMC storage and case aside. Let's get this heatsink out here. The heatsink is available in a few different colors. This was the only color that was available when I purchased it, but it's a nice bright blue color that is the Lipotato color apparently. And you can see there's just these little holes in the board that it snaps into. There's one there and then another one diagonally across there, and it fits across these two chips that are on the board, so it kind of covers them up like this. But we've got to peel off this backing tape first so that we have the heat transferring kind of tape on there, and then I'm just going to press these little black spring-loaded black tabs through. That one went in pretty easy. This one, because there's other stuff around it, sometimes it takes a little bit more pressure to get this one through. So just we'll give it another good solid press. There we go. And they're spring-loaded, so that keeps the right amount of tension on the heatsink and on the chips, and keeps the board nice and cool. It's not critical, but I think it makes the board look a lot nicer, and it does reduce the operating temperature by maybe 5 or 10 degrees depending on what you're doing. So we'll put the USB adapter in, and then we'll plug this little micro USB to barrel connector adapter in. Sorry, we're putting the Wi-Fi adapter in. So now we've got the basic assembly there minus any storage. We're going to flash the storage later and get this device ready to go, and we'll get it booted up. So for the next step, we're going to want to download an image for this small computer and get it flashed. So to do that, open up a web browser here and go to Libra Computer, and we go to the products section. The board that we're using is called the Lipotato, or the Potato, I guess. I don't know the history behind the name, but that's the board that we're going to be using. This one is, again, $30 in the US for a 1 gig version, or $35 for a 2 gig version. So at least by today's prices, it's pretty affordable compared to Raspberry Pi and most of the alternatives. So if we go down here to downloads, there are a number of different options. The one that I found that works really well for Roon is this Armbian distribution, and it's based on Ubuntu. So if you're familiar with Ubuntu, it's going to be pretty familiar to you. So this took us to now the Armbian website, where we've left the Libra Computer website and gone to their website. We scroll down a little bit, we can find Lipotato here again. So we'll click on that. And then there are a couple of kind of primary releases here. Armbian Jammy, it's based on Ubuntu packages. But I found that one uses a little bit more CPU. It's a little bit fatter. For Roon, we want something that is small and tidy as possible. And so this Armbian Bullseye Minimal CLI is a version that I found works really, really well. So I'm going to click on that and download it. We'll just give a second to download. I downloaded it already, but we'll just download it again real quick. It only takes a few minutes to download. Part of the reason is because it's pretty small. You can see here it's only 344 megabytes in size. So it'll just take a moment to download. All right, that download is finished. So we can get out of here. And we're going to want to put that microSD card in the laptop. I've done that already. So I'm going to go ahead and open up Etcher. So actually, let me show you the URL in case you don't have Etcher. If you just type for etcher.io, that'll kind of redirect you to Balena Etcher, and you can download this program. It's a good program for Windows, works on Mac OS as well. I think there might even be a Linux version, although you don't really need it for Linux. For flashing these images. One of the things that's nice about this newer version of Balena is that it you don't have to do anything fancy to uncompress these files that we downloaded. If we take a look at the file that we downloaded, it's a .xz file, which usually requires 7-zip or some other third-party application to unpack, but Balena can read these things directly now. So let me go ahead and fire Etcher up, and we'll go ahead and find the image. Actually, let me quit this and start it over again, because it's still has my previous flash running. So let me just restart it, get it over here. We're going to flash from a file, and we'll just choose this file that we downloaded. And it shows as .img. It's actually an .xz file, but since Balena can read this thing, we can just use it directly. I've put the 64 gig SD card in my laptop's micro or SD card slot. You may need an adapter or a separate reader, but my laptop has an SD card slot in it already, so it can kick flash. Windows is going to ask me if I'm sure that I want to do that, because it requires sort of elevated privileges. You can see in this first step, it's decompressing that image. This is something that we used to have to do as a separate process, but it's nice that Etcher can handle that now. Once that finishes, it'll go ahead and flash the image to the card. I may pause the video a little bit so you don't have to wait for that, but we'll wait until it gets started. So there you go, flashing is on its way. Once flashing finishes, it's going to go through this validation step, and you could skip this optionally. I usually let it finish. It only adds another 20 or 30 seconds to the process, but it's good to make sure that that flashing process was successful. I think what it does is it rereads the card and compares what's on there to what's in the image file. I'm not completely sure. It seems to run pretty quickly, but it's worthwhile to do. All right, now that that is finished, the next step is to eject that card, and you'll eject the card safely however you do that with your operating system, and then we can move it over to the potato board. So I think on here I can right click on this, cancel. Oh well, it's not going to let me do anything fancy. All I want to do is eject the card. All right, so that'll let me safely eject it, and then I can move it over to the little Raspberry Pi board. So let me walk you through what that looks like. We have a boot image flashed onto our microSD card. I think I said Raspberry Pi, but it's the Le Potato board. So we'll connect power to this thing and go through that first boot process. I just connected power moments ago. Hopefully I'll see something on the screen. There we go. So what you'll typically want to do is connect an HDMI monitor. It could be an HDMI television or a spare computer monitor or something like that. You'll also need a keyboard that you can connect to this board. Any USB keyboard should work. Getting my USB keyboard ready. Had some problems with my HDMI capture board, but this is what the first boot looks like. The first step that it does is, once it kind of gets the kernel loaded, is it resizes the file system. So the image was pretty small that I flashed on the card. We saw it was like 300 something megs. I think uncompressed it's around 1 gig. But the microSD card that we have is 64 gigs. And so the operating system kind of pre-boot script is going to resize the root file system to use all of the space on that SD card. So it'll use all 64 gigs. Now that we're up and running, we're going to put in a root password. We're just going to put in something simple. It's probably going to complain that it's not very secure, but it's good enough for what I'm trying to do. And now it's asking you to create a regular user, a non-root user. It's worthwhile to do this, so I'm just going to use my regular Unix username, and I'll put in a simple password as well. If you're going to use this in a more secure environment, you'd want to use a better password, probably. It's going to ask you for your real name. It'll just update the user database with that. If you've got a compatible wireless adapter connected, and the one that I recommend you purchase is compatible, then it will let you configure your Wi-Fi networking. If you've got a wired Ethernet connection, then you won't get prompted by this. It'll connect to your wired network instead. But since this is Wi-Fi, we've got to put in credentials for this thing. Hopefully I typed that right. We'll find out pretty soon. If you're connected to your network, it just makes things a lot easier. So once you see a wired connection up at the top, you can go down, tab down to quit to get out of this menu. And then now that it's on the network, it's able to kind of ping out to the internet from my location to figure out my correct time zone. It makes the setup a lot easier than if you're not connected to a network. If you're not connected, it's going to ask you a whole bunch of questions because it can't figure out what the answers are automatically. So I'm going to say yes for this. There are a few languages that are common in Phoenix, Arizona, but I'm going to choose English for this one. It'll take a few seconds for it to generate locale information for the English language in this environment, so we'll just wait for that to finish. Come on. And let's drop this down to a root prompt. There are a few commands that I can type right now just to kind of see what's going on. I can see what our IP address is by typing IP space A. It's short for IP space address, I think, or something like that. And we get a lot of kind of gobbledygook out here. But if we look down underneath ETH0, or underneath the ETH0, we have nothing but the third wire adapter. That's that 3 colon that you see there with WLX90, blah, blah, blah. That's the wireless network adapter that I have. And a few lines below that, we can see that there's a IP address under iNet called, the IP address is, in my case, 172.16.8.246. So we're going to want to remember that IP address because we're going to log into it over the network. We can do a netstat command to see what services are listening, and I can see that there's a SSH server listening because I know that port 22 is SSH. There's not much else going on this machine, but we should be able to log into it with SSH. So let's go ahead and try to do that. So I'm going to go over here. We don't need a web browser anymore. You could use like regular Windows PowerShell or the command prompt in Windows. I've installed this other terminal that I like a little bit better. So it makes things a little bit more convenient. So I'm going to use this. You can see I was trying to get my window size correct here. But we want to SSH to that new address, that new machine. If you've SSH'd into machines before, you may end up with a warning message that I'm going to show you, and I'll show you how to work around that. Let's try to SSH. I'm going to use my username since I created a new username, 172.16.8.246. And it's going to give me an error because I've logged into a machine with the same same IP address before, and it's telling me that there's an error that the host key doesn't match. So there are a couple ways that I could fix this. The easiest way is probably just for me to remove my SSH known host file. If you're fancy, you could edit it and remove line 26 and probably be able to get in just the same. I'm going to log into this thing now, put in the password that I put in, and now I'm logged into that little potato board over the network. So, so that's kind of cool. The nice thing about this is it's just a little bit easier to configure than having to have that HDMI monitor and keyboard connected. So now that we're set up, a couple things that we're going to want to try to do, but the easiest thing would be we're going to want to set this thing up for Roon, and just one second. So there are a number of steps that we follow to get this thing set up for Roon, but I wrote a little script to make the process easier, so we're going to go ahead and give that a try. I put a link to this script in the Roon community, and I'll put the link in the description so that you can find it easily. But essentially, we're going to read some default variables from a file called etc os release, and then we're going to download a script and run it. So I'm going to copy this text here and then go to my potato window and paste these two lines in. And it's asking me, since I'm having to do something under root, it's asking me to put my password in. I'm going to run a privileged command. I'll put my password in, and first thing it's doing is updating the packages that are on this little computer. We want to make sure that we have all the latest packages before we get too far along. So this process might take a little while. If it does, I'll pause the video a little bit to let it finish. Here it's installing some dependencies that we need for Roon, including libasound. That process will finish up here in a bit. I put this script together just because it's not everybody's comfortable with the Linux command line, and having to type a whole bunch of commands to get things configured can be a little bit confusing. And the script automates all of that stuff. You can always take a look at the script later on and decide if you want to run it or not, or if you want to do some of the steps manually. I'll show you how to take a look at the script without running it once this finishes. So installing another dependency that Roon has. Roon needs this ALS utils package installed. So it's pulling this down from the internet and installing it as well. Let that finish. Yeah, you can see it's hot here in Arizona, 95 degrees out right now. All right, and then we needed bzip2 installed, and it verified that that was the case. And now it's pulling down the Roon Bridge software from Roon Labs, and it's gone through and installed that. And Roon Bridges should be running on the machine, and the script shows a list of audio interfaces. Right now, the only audio interface that we see is the one that's built into the little computer. You could actually connect a pair of headphones or powered speakers to the little 3.5mm jack on it, and you get sound out of it. It's not particularly good sound, but it's something that you could use to kind of smoke test and see if things are working. So let's take a look at that script, just so you can see what it does. So if you're curious later on, instead of downloading it and running it, we're just going to download it and send it to a little pager program called Less. And Less is nice because it lets us kind of through things. I don't want to go into a ton of details, but you can look at it later on. Basically, it's updating the list of packages, and then it goes through and downloads some dependencies. Roon needs these packages. This is documented on Roon's website as well, what packages Roon needs before it installs it. And then we turn off the serial Getty, just saves a little bit of memory. It's not critical, but something that I've noticed that Diet Pi and some other releases do, so I added some capability for that as well. And then here's where it actually downloads the Roon bridge installer from Roon Labs. Manufacturers aren't allowed to supply this to end users. End users have to download this themselves, and so this automates the process of downloading that and unpacking it and running it. And then you saw where we listed out the audio interfaces. So that's pretty much all the setup here. We could go ahead and make this be an endpoint by attaching a DAC, but what I'm going to do instead is walk you through the process of attaching that eMMC storage device and getting that flashed so that we can use that instead. And then once we're on eMMC storage, I'll go through the process of configuring this thing for Roon, which you're probably already familiar with, but if not, please stick around. So let's go ahead and shut this thing down. We want to shut it down before we make any electrical connection changes. So best way to do that is sudo, you can do shutdown -P for power off, or you can sometimes just type power off. But that will get this little device shut down. And yeah, then we'll be able to connect the eMMC storage. Just making sure that the device shut down correctly. We're now going to attach the eMMC storage to the Potato board. It goes on the underside of the board where you can see these little pins are. There's a little rectangle that marks where it should go. You can see the pins on the eMMC card need to line up with the pins on the board. If you line the top of the eMMC card to the top of that little rectangle, it'll usually snap into place. Don't put too much pressure. You'll know that it's on if it doesn't fall off when you turn the board upside down. It's just held on there by friction. So we're going to leave the microSD card in the device. It's going to boot from the microSD card when both storage cards are present. We'll connect power and get this thing booted up, and then we'll flash an image onto the eMMC storage. All right, now that we've gotten the eMMC storage attached to the Potato board and we've booted it back up, let's log in and see if we can get that eMMC storage flashed with an operating system. We'll log back in, and I'm not really sure what happened here, but earlier today I was able to download this link, but when I click on it now, it says that it's not found, at least for the US, for Armbian Bullseye. So it could be that they're doing some maintenance on the site. We're going to unfortunately need to pull this image from the EU instead. The other option would be to copy it from my Windows machine, but I'd rather kind of do this all in one step. So hopefully by the time you get around to doing this, these links will actually work. I just checked the EU link and it works okay. So I'm going to copy this link address. I'm just going to right click on, again, Armbian Bullseye minimum CLI, same page we were on before, but instead of the US image, which seems to be broken, I'll click on the EU one. So copy link address. And in Linux, well, actually before I do that, let me show you where the storage is. So in Linux, I can use the lsblk command to see what block storage devices I have attached. I can see this 64 gig device here. That's what I've booted off of. That's that little micro SD card. I also see this around 16 gig device here. This is our eMMC storage. So eMMC storage is mmcblk1, and my boot drive is 0. So you just need to make sure you get the number right. These numbers might be a little bit different when you go to run this. So in Linux, to download a link, we're going to use curl. And we'll paste in the URL here. Now this is going to be an XZ compressed image, so we need to uncompress it. And in Linux, I can do that with a program called xzcat. Uh-oh. And then I'm going to write that out to the eMMC storage. In Linux, when we're doing copies from one drive to another, we use a command called dd, or a disk-to-disk copy. By default, it's going to read the output of all that we've typed in so far. I just need to tell it where to write it to. So we're going to say that the output file is dev mmcblk1. The dev piece is important. All the Linux device drivers are under /dev in that folder. So dev mmcblk1. BLK1. I need to specify a block size. By default, the block size is going to be kind of small. I'm going to specify around 0.5 meg. Block size is equal to... And the other thing that's important to remember is that if I'm writing to device files, I need to do that with root privileges. So I'm going to do that under sudo. And let's get this going here. I cannot believe this is not working. All right. I guess it was asking me, looking for my password, so I need to run this command again. I just typed sudo and then just some random command so that I can get my root password entered, and I think that this will probably work better now. Let's find out. Yeah, so if you get that error, if you haven't used sudo in the last 5 minutes, you have to give it a password. I think the way that this program was working, it was trying to read my password from this long curl command. So, all right, so thanks for bearing with me there, but you may encounter some of these issues yourself as well. So, so we can learn together on this. So we're downloading this file, and at the same time we are uncompressing it, and at the same time we're writing it out to the SD card. It's an efficient way to do it if we're reasonably confident that the URL is correct and that, that we've got our sudo password entered already so that it doesn't break. And the nice thing about the command is if it does fail for some reason, you can just start it over again. It's not gonna create any problems. But looks like it's getting close to being finished. We'll see. Even when it gets to 100%, it's still going to take a little while to finish writing out the rest of the information to the card. We'll just give it another few seconds or so. Whatever it managed to buffer into memory, it's going to have to close that stuff out. So we can see that it wrote about 1.3 gigs out to the card. And that seems right. If we were to actually download and uncompress that 300-something meg OS image, we'd get about 1.3 gigs. So this looks good. We do an LSBLK now, we might see an additional partition because that image file has a root partition in it. We can actually check the file system and make sure it's okay with FSCK, and then let's just copy this image here. So that I don't mistype it. Dev eMMC BLK1P1. This will just run kind of a file system check to make sure that that it's happy. It also reports what that file system's name is. It's armb root, which sounds like it could be right. I could also mount that file system to a directory on this little Raspberry Pi if I wanted to. And I've mounted it to /mnt, which is a popular Linux mount point just for checking things, a temporary mounting. And if I take a look under /mnt, these are all the files that were in that image that got flashed to that eMMC storage. So that eMMC storage is mounted under /mnt. And if I take another look at just the root file system on this device, I see almost exactly the same thing. So it looks like that image mounted just fine. Now I'm going to unmount this image because we're going to shut this thing down, and then we'll remove the microSD card and try to boot from eMMC. So that'll be the next step. Let's go ahead and power off. All right, I've just connected power, and we can see that we're already booting from the eMMC storage. You may notice that it boots a little bit faster than it did from the microSD storage. When I did some testing, the eMMC storage was about 10 times as fast for reads and writes. So it's generally quite a bit faster. Is the speed necessary for Roon? Not really, but it's only $10 to add this little upgrade, and I think it's nice to have, especially if you're going to use this device for other things besides Roon. We're going to go through the same process again. We've got to put in a password and and get it set up on the network and everything else. So I'll just do this as quick as I can. Same exact process as before. I'm going to connect via wireless. I'll go down and choose my wireless network and tab down to quit. And I'm going to set my defaults from my location. Again, we're going to use English, and then we may notice that this process runs a little bit faster. I can't remember if this is I/O intensive or if it's CPU intensive. If it's CPU intensive, it won't be any faster. I/O intensive, then it will be faster. So we'll see. All right, now we are on the network. I'm going to check my IP address. Since my router gives the same IP address as long as the MAC address matches, probably going to be the same. We look down here under the Wi-Fi wireless interface. It's 172.16.8.246. But I'm probably going to have to clean my SSH host key again when I try to log in. So let's go back here and do that real quick. Shouldn't need Chrome too much anymore. So I'm going to go ahead and let me get the right keyboard here. I had a wireless keyboard that I was using for the potato board. Get rid of that known host file and then SSH back in. Now I'm logging in for the first time with that eMMC storage. We'll still need to go through the process of setting this thing up for Roon. So I know I said that I don't need that browser window anymore, but we kind of do, so that we can copy these commands again. So we'll do that. And it's going to go through the same process of updating the packages and installing the dependencies for Roon and getting Roon started up again. So we'll go through this real quick. Good review though, so that you can see how to do this. If you not comfortable with it, you get to look at it a couple of times. And we're pulling in those dependencies for Roon. Normal for this process to take a minute or so. On this page as well, I go through some additional steps for enabling AirPlay if you want to have AirPlay enabled on these devices. Also, I modified my script to add some commands to do that too, so you can experiment with that if you want. If you're an Apple user, AirPlay can be a convenient way just to stream audio to this little endpoint while at the same time having decent audio video sync. So you could watch YouTube videos or Netflix or whatever and have the audio coming through the Raspberry Pi instead of your mobile device or laptop, which might be more convenient. If, for example, if you have a laptop sitting on your lap and you want the sound coming out of your big speakers down at the end of the hallway, you can do it that way. Now we'll go ahead and install Roon Bridge, downloading it directly from Roon Labs. And that part's done. All right, so the next thing that we're going to want to do is connect a USB DAC to this little board so that we can get it configured. You can see right now the only audio device that we see still is the one that's built into Roon. So I'm gonna, you can't see what I'm doing, but I'm unplugging my keyboard dongle and plugging in a little USB DAC. Just got a little simple one from iFi. Hopefully I've managed to do that without disconnecting anything else. Let's find out. So to see what audio interfaces are attached, I can use a command called aplay-l. And I see here that where before there was just the internal DAC, now I have this Go Blue device. It's a USB audio device that that I can use for doing some testing. So as soon as I plug that in, Roon is going to recognize that, or at least I claim it will. So let's go ahead and find out. We'll bring up Roon, and we're going to go down to Settings and Audio, and we're going to look for this Potato board. It's the default host name for this machine. You could change the name if you wanted to, but doesn't matter. If you have more than one, it might be worthwhile going through the effort. There's an RBM config utility that you can install to simplify that process. This is the internal headphone jack that doesn't sound very good. We're not going to use that. But we do have this Go Blue. I've set this one up before, so it kind of read in some defaults, but we'll just skim through these really quick. This particular device doesn't have any MQA abilities. I'm going to go with fixed volume here. And after I make that change to fixed volume, I'll go down to advanced and make sure the other settings look correct. So this is a 2496 capable DAC. I'm going to have the MQA core decoder turned on in Roon because this device doesn't know anything about MQA. And I usually force max volume on playback start if I know that I'm not going to use device volume, which is going to be the case for this thing. So I'll set that, and now I can go and select the audio zone and customize it a little bit more if I want to. I can choose an icon that's suitable, or choose the default one if this is a Roon tested DAC. I usually turn volume leveling to auto with a target of -18 LUFS. If you're into volume leveling, you can do that as well. It's optional. And yeah, at that point, we should be able to play some music to it. And there we go. It looks like I've used this one before, so I have some DSP presets. This is for a pair of hi-fi man HE 400SE headphones. I can turn crossfeed on. I'm using a 65,000 tap filter to make the output sound a little bit nicer with those headphones. So that's kind of at a high level how we can get these things set up. I'll show you a picture real quick of what this little DAC looks like. But you can use any USB DAC, including that larger Gustar DAC that I showed you at the beginning of this whole thing. So really, that's pretty much it. One thing that I should mention, because like I said before, you could connect a laptop or a desktop computer to a DAC instead. But in addition to the power savings, some folks claim that a little board like this is going to sound a little bit better because it's going to generate less noise to go downstream to the DAC. I don't know, maybe so, maybe not. I'm not sure that I've heard a huge difference, although I found that these little boards can be a little bit more reliable if you have a desktop computer that's busy doing other things. But what I do know is that these are pretty inexpensive, right? You could buy an iFi Zen streamer for $400. It's a really nice device. But this whole kit, all that you see here, is around 70 or 80 bucks, depending on what parts you spec for it, and whether you decide to use Wi-Fi or just plug into a network cable. So it's pretty inexpensive, and I would argue that the performance in terms of sound quality, as long as you're using it with a modern DAC, is going to be on par with much more streamers up to $1,000 or so. At least that's been my experience. So when you want to have more DACs in your house connected and enabled through one of these little network audio adapters, you can call them a network audio transport or network audio bridge. There's several different kinds of names for these things. You can do it very inexpensively with these little boards. And it's a fun little project. Once you've done one or two, it's pretty easy. You can help your friends do some of them as well. And it just makes using Roon much more fun when you have more output spread throughout your house. So this project is kind of like a project of building a Roon core using the Roon rock kit. Roon optimized core kit out of an Intel NUC. This is kind of the analogous project for building an output device. So I hope you found this video and process helpful. If you got any questions, leave them in the comments below, and I'll do my best to answer. Cheers.